Okay, so here we're doing problem 37, and I have here what it says in the problem. It has a 175 gram glider on a horizontal frictionless air track attached to a fixed ideal spring with a force constant of 155 Newton meters. That's the force constant, that's the mass. Instant you make a measurement on the glider, it is moving at 0.815 meters per second, so that's the velocity initial. And then we have, and it is 3 centimeters from equilibrium point, so 0.03 meters from its equilibrium. It says use energy conservation to find the amplitude. So this is the energy conservational formula. So first, to find the amplitude, we're just going to plug in these numbers. So we have 1/2 times the 0.176 times the initial velocity, which is, did I have that right? Yeah. So, which is 0.815 squared plus 1/2 times the spring constant times the distance from equilibrium squared. Is that equal to 1/2 times the spring constant? And there, finally we have amplitude. And basically you're going to put this all into your calculator. You'll multiply this by 2 and divide by 155 and then square root it all. And that will equal A. So when you put that all into your calculator, you get 0.0406 meters or 4.06 centimeters. So that is part A, to find the amplitude. So I'm going to erase this, and we're going to do part B. So part B says the maximum speed of the glider. So now we're trying to find the maximum speed. So since we know the amplitude, we're going to just plug in the numbers again. So we know that the maximum speed is when it goes right through the center. So this part right here is going to equal 0. So you plug in the mass and you divide. So you get the square root over this number here. Divided by the mass, 0.1. B, and the velocity comes out to equal 1.208 meters per second. And that's the fastest it will go, because it will be traveling through the center. So, and there's part C. So part C says, what is the angular frequency of the oscillations? Ta-da! So, angular frequency equals the square root of k over m. We know what k is. It's the 155. We know what m is, 0.176. Plug that in, and we get 29.76 radians per second for our angular frequency. And that is number 37.